Ya. Alright. Hai. Assalamualaikum warahmatullahi wabarakatuh. Okay, so welcome to my first um, online class. Okay. Alright, so I think there's a lot of you who requested for English version, so I'll try to balance between the two lah.
Okay.
Right. So my slides are basically in BM, tapi ada juga here and there, but I'll translate for you. That's, no problem. Okay, so today we are going to look at heat, right? Right. So heat, actually heat ni introduction to the topic. Dia sebenarnya it's not that hard lah. Okay. Kalau you tengok, you flip through every year's punya questions. Okay, normally dia banyak cover on latent heat and specific heat capacity, which is muatan haba tentu dengan haba pendam tentu. Okay, alright. So basically these are the things that you need to know in this chapter. Apa yang perlu anda kuasai dalam bab ini. We have okay.
Teacher, what is pendam?
Haba pendam tentu is latent heat. Just another term in BM, okay?
Okay.
Alright. So in this chapter we have you have to know maksud suhu. So basically memanglah I already scale it down to things that you really need to know in this chapter. Okay, so first you need to know what temperature is in terms of definition. Okay, and you also need to know the difference between suhu and haba. Okay, perbezaan antara suhu dengan haba. Temperature is suhu, haba is heat. And then you need to know about the usage of thermometer, a few types of thermometer that's been used in daily life, in lab, okay? And then we also have keseimbangan terma. So keseimbangan terma is thermal equilibrium, okay? And then here also application, okay? Application of keseimbangan terma. So you need to know the meaning and what are the applications related to it. All right. Then we're going to look at muatan haba tentu in terms of definition. Okay, muatan haba tentu in English is specific heat capacity. Okay, specific heat capacity. And then we are going to look at the definition and the formulas, also the unit. And then after that, we're going to look at the applications. So applications here yang normally selalu dalam trials, dalam exam dia akan tanya pasal value darat dan value laut. Okay. Yeah. Wait, I think I'm going to record. Okay, record. So whatever questions that you have, feel free to just chat around here, okay? I'm still admitting people, so bear with me. Okay. All right. Therma is actually heat. Okay, thermal. Is in English is thermal. Thermal is heat. Okay, whatever related to heat, it is just a scientific connotation. Yeah. Okay. Okay, back to our slide. All right. So, right, back to slides. Alright, so maksud suhu. Okay, so maksud suhu is temperature. Temperature is degree of hotness of a substance. Okay, ataupun darjah kepanasan sesuatu bahan. Right, we also have haba. Okay, haba is a type of energy. So haba is actually yang penentu suhu. So the banyak haba means suhu tinggi. Sikit haba means suhu rendah. Okay, right? So you don't get confused with these two. Sebab selalunya exam bila dia tanya you haba, you akan confuse it with suhu. So basically haba is what decides berapa you punya suhu. Okay, kalau badan you banyak haba kan, you panas, you demam, means suhu you tinggi. Okay. Alright, and then we the unit, the SI unit for haba is actually joule because haba is a type of energy. Okay, whatever type of energy we give it, the unit is in joule. So I nak refresh sikit, apa lagi bentuk energy yang ada? We have kinetic energy,
Potential energy.
yes, potential energy, other types of energy, they are all in joule. Even calories. Makanan kan, you makan kan, berapa calories, they are in joule. Okay?
Yeah.
Alright, so suhu, we in this chapter memang kita guna degree C dengan Kelvin, but the SI unit for temperature is Kelvin. Okay? The commonly used suhu is degree C. Alright. So kita tengok juga these two thermometers yang selalu masuk dalam exam. We have two types. Okay, one is alcohol Kalau alkohol dalam dia kalau merah. Okay. Another one is mercury. Ini yang paling selalu gunalah dekat lab, dekat klinik, dekat hospital, use thermometer mercury. Alright, so there's reasons kenapa kita pakai mercury dengan alkohol in thermometer. It's because satu dia mudah untuk dibaca kerana cecair dia berwarna legap. Legap in English is opaque. Okay, opaque tu maksudnya it's not invisible lah. Okay, it's not invisible. Kalau invisible is confirm you tak boleh baca kan. Alright, so mengembang dengan seragam. Mengembang dengan seragam ni maksudnya it expands uniformly. Tak adalah macam hari ni dia macam malas nak kembang, esok dia rajin nak kembang, tak. It always expands regularly. Okay, uniformly. You know, I have to look at the comments. Okay, welcome to those who just came, those who just joined. Alright. Ini ulang kaji je tau. I'm not gonna go like so deep into the chapter sangat. So okay, korang pun macam puasa-puasa, relax, you know, ingat-ingat balik kan, right? Alright, next is because mercury and alcohols are good conductors. So they are good heat conductors. Atau haba yang tak baik, it's gonna take a long time for you to take your suhu by then. Okay? Alright, so and then next is tidak melekat pada dinding kaca. So bila dia expands, it won't stick to the capillaries. Okay? And then kita ada takat didih tinggi dan takat beku rendah. Right? Got it, huh? So basic about the usage of mercury and alcohol. Okay? Next, we have okay. Alright, so how to increase thermometer sensitivity? Selalunya kalau dalam exam, trial ke, SPM ke, right? Dia akan bagi soalan instructor or essay, okay? And then they ask you how to increase your thermometer sensitivity. So here are a few things that you need to know. So dalam ni we have the capillary tube atau tube capillary. So lagi halus meaning lagi sensitif. Okay? And then here we have the berbuli kaca ataupun bore. Mesti halus supaya bila halus the heat can be absorbed quickly. Okay, to transfer to the mercury. Okay? And then berbuli kaca mestilah berdinding nipis. Okay? So the thin wall will help to increase the heat absorption. Okay? Right now? Okay, next. Okay, this is the most famous subtopic kalau masuk dalam paper 1. Almost every year dia akan tanya at least one question pasal thermal equilibrium. Okay? Maksud keseimbangan terma. Okay, so you need to know what keseimbangan terma is. Okay, now, so the concept is that when you have two objects of different temperature lah okay, katalah you ada satu besi panas, satu besi sejuk, and then you letak dia dekat or you letak dia, you know, in contact. So basically the heat from the hot object will transfer to the cold object. Okay, so dia akan keep on transferring until at one point they both reach the same temperature, which means they are now in thermal equilibrium. So bila haba daripada benda yang objek yang panas tadi, dia bergerak ke objek sejuk, so dia bergerak transfer pindah, and at some point dua-dua ni dah sama suhu. Okay, so ini bermaksud keseimbangan terma telah tercapai. Okay, so apa maksud lain keseimbangan terma is apabila aliran haba bersih sama dengan kosong. Apa maksud aliran haba bersih?
Flow of heat.
Yes, the flow of heat. Okay, I bagi you as one analogy lah Okay, Kalau kerja dia dapat gaji, right? So gaji is duit masuk, right? So bila you bayar, okay, you know all the expenses, you beli shopping is duit keluar. Okay, so kalau duit masuk 1,000 and you spend 1,000, that means gaji bersih you is 0. Macam tu. Okay, so people always confuse aliran haba bersih iaitu net flow of heat 0. Maksudnya dia still ada haba, still ada the pergerakan haba. Maksudnya sini pergi ke sini, haba is still moving. It's just that daripada hot to cold lagi banyak compared to cold to hot. Okay, so the heat flow is still there, but keseimbangan terma, or we call it thermal equilibrium, is only achieved when heat from this object to that object dengan this one is sama. Katalah here is 20 joule, let's say lah 20 joule from this object to this one, and 20 joule from this object to that one. So bila you punya object sama, means 0 lah. They cancel out lah macam tu. Alright? Okay? Alright. So a few applications for keseimbangan terma is when you put your food in the freezer. For it to freeze. Okay. So you set your freezer to be -2. Okay. So after katalah let's say 1 hour, your freezer and your food dia jadi same temperature. So that is when the thermal equilibrium is achieved. Apabila makanan mencapai keseimbangan terma dengan peti sejuk. Okay, right. Okay, so next is another example is the usage of thermometer. So kalau you pergi klinik, right? Okay, ni kita pakai thermometer biasalah. Okay, thermometer yang bawah ketiak tu, bawah lidah. Okay, so your doctor basically akan letak you punya letak thermometer kat bawah lidah, and he will wait for a while. Why? Sebab for it to allow heat daripada badan you to transfer to the thermometer. Okay, so after some time bila you punya badan, okay, suhu badan dah sama dengan suhu thermometer, then your mercury will stop expanding. Only then your doctor akan baca. Okay, so kalau nak tulis ayat yang ayat exam lah kan, apabila mercury berhenti bergerak, ini bermakna suhu badan dan suhu termometer adalah sama, iaitu telah mencapai keseimbangan terma. Okay, right? Okay, next. Oh, there's still people coming in. Okay, any question, guys?
So far, no.
So far, no. Okay, so very easy, yeah. You can check here. Like from time to time, I'll check. Okay. Okay. Next. We skip that one. All right, we'll just go to this one. Okay, guys. So let's test. Number 1. Antara ciri-ciri berikut, yang manakah digunakan dalam fungsi termometer cecair dalam kaca? So which of these is used in thermometer? Okay.
Ketumpatan cecair.
Ketumpatan cecair, isi padu cecair, okay, actually jawapan dia is isi padu G-same. G-same mesti tetap. Okay, so it's B. Next, number 2, antara kaedah berikut Mana boleh digunakan untuk meningkatkan sensitivity. Okay.
B.
Alright. Yes, so B. Tiup kapilari yang sempit. Okay, yang lain is off.
Cikgu,
Yes.
soalan satu tu A dengan B maksudnya sama ke?
Tak, this one is lah. Sepada cecair yang berjisim tetap, sepada jisim tetap cecair. Yeah, more or less. Yeah, it's actually jisim. Padu cecair yang berjisim tetap. Padu jisim tetap cecair. Padu jisim tetap cecair. Ya, lebih kurang lah A dengan B tu. Lebih kurang. Padu cecair yang berjisim tetap. Betul lah. Sama je. Okay, so it's B. A tadi juga. Sedangkan jisim tetap. Okay. Right, so this one. Raja 3 menunjukkan 2 bongkar berlainan bahan, air dan suhu.
Donkey.
Alright. So, keseimbangan terma dicapai apabila, okay, korang kalau tengok soalan ni, terus tengok net heat of transfer lah. Okay, net transfer of heat is 0. Okay, so D, donkey. Right? Okay, so these are real SPM questions. Okay, let's try this one, number 18.
A.
Alright. Sup panas dituang ke dalam sebuah mangkuk. Kenyataan manakah yang betul mengenai pengaliran haba? Alright. So it's A, pengaliran haba bersih dari sup panas ke mangkuk. It's always from a hot object to cool object. Okay, that's how the heat is moving. So, yeah. Check. Alright, feel free to write down your answer dekat chat. Alright, next one. Number 23. Okay, number 23. So we have 2 beakers with different volume of liquid X but same initial temperature. Okay, suhu awal dia sama. Lepas tu, kedua-dua bika kemudian dipanaskan dengan amount tenaga haba yang sama. Maksudnya you panaskan katalah for 5 minutes dua-dua. Dua-dua for 5 minutes and then you stop. Perbandingan manakah yang betul tentang bacaan termometer P dan termometer Q? Okay. So obviously yang mana lebih panas? A lah
A.
Yes. Okay. So these are real SPM questions, selalunya dia taklah macam kejam sangat. Okay. Selalunya kalau korang cuba soalan-soalan buku rujukan tu, they tend to be a bit susah. So yeah, you try SPM questions, they're not that hard. Sometimes it can be tricky, but it's quite jelas lah. Okay. Next. Okay. Alright, so we have now muatan haba tentu. Okay. Specific heat capacity. Right, specific heat capacity. So, sebenarnya dia mesti akan tanya you, what is the definition? Apa maksud muatan haba tentu? Alright, so there are 3 keywords that you need to hafal, memorize in order for you to get full 1 mark. Okay, selalunya soalan definition, dia nak you bagi lengkap. You tak boleh macam, you mesti ada all the keywords needed lah. So that's the thing about definition question. It's only 1 mark, but you still have to get complete answer. Okay, so specific heat capacity. First thing, you mesti ada this word, tenaga ataupun haba, tenaga ataupun haba, or you can say tenaga haba yang diperlukan oleh 1 kg bahan untuk naik sebanyak 1 degree. I dah memang ringkaskan untuk you dah. Okay, so because it all comes down to the formula Q equals to MC theta. Okay, so kalau you tengok balik, C is your muatan haba tentu kan. So kalau you letak C dekat sini, dia akan jadi apa? Q equals to M theta. Right. Kalau you bawa ni pergi sini, right. So nampak tak? Muatan haba tentu ada 3 benda. 1, 2, 3. Because they reflects here. This is the heat ataupun tenaga haba. M is your mass and theta is actually your temperature change. So you kena ada tiga-tiga ni because your definition reflects your formula. Okay? Alright, so the SI unit pun mestilah ada 3 benda. Okay? So you akan ada J, joule untuk haba, over, apa ni? Over kg and degree C or Kelvin. Okay? Kali ni kita pakai degree lah. Alright, so what is specific heat capacity? So it means that kalau you tengok specific heat capacity of substance, okay, dia menunjukkan betapa whether it's a good heat conductor or it's not. Okay. Kalau you tengok macam ni, I'll show you these two je lah. Okay, one we have water, air. If you compare to oil, minyak. The specific heat capacity for water is 4,200. Besar kan? Banding dengan minyak. Okay, apa maksud 4,200 ni? Apa maksud 540 ni? Okay, kita tengok air.
The 540 joules is used to increase to 1 Celsius by 1 Celsius.
Yes, that's right. So let's say if you have 1 kg of water, okay, 1 kg of water at 25 degrees, okay, so you nak naikkan dia to 26, okay, you nak naik dia by 1 degree C, you need 4200 joule. Banyak kan? Banyak lah. Okay, berbanding dengan minyak, you ada 1 kg of minyak, you nak naikkan from 25 to 26, you only need 540. Nampak? 540 je. Sekejap je. Maksudnya you letak sekejap je api, dia dah panas. Yang ni you kena letak lama sikit. Sebab dia perlukan lebih banyak. Okay? Right. So, yeah. So, kita tengok sikit. These are, tak naklah highlight banyak-banyak kan. But, ini yang selalulah yang masuk exam. Cikgu highlight. Yang kita selalu kena tahulah Alright. So, here I give you few substance. And their specific heat capacity punya value. Okay, kita ada water. Water being the biggest here. And then kita tengok iron. Iron is besi kan. So awak tengok semakin dia kurang, kalau semakin cepat maksudnya kalau makin kecil nilai, maksudnya benda tu makin senang panas. Okay. Water sebenarnya dia tak senang panas. Dia sebenarnya water ni dia boleh simpan heat. Dia boleh simpan haba. That's why kan kalau kita demam, what do? Doktor akan cakap apa? Minum air banyak-banyak. Why? Because bila you minum air banyak-banyak, dia akan tarik all the heat from your body and then dia akan buang through your urine. Dalam kereta, ingat, dalam kereta. Kalau air tak ada dalam radiator, what happens? Your engine akan cepat panas. So that's why you put in water. You make sure your water level in the radiator sentiasa up to date, sentiasa penuh, and then you akan mostly akan letak coolant lah kan. So that water actually helps to sedut, to absorb all the energy tenaga haba daripada engine kereta, so that your engine kereta tak adalah cepat panas. Okay, right? So you tengok balik here, We also have copper. Copper is basically kita guna untuk buat wires, okay? Right? Okay. Glass. Glass pun agak cepat panas jugalah. Okay? Sand. Tengok. Sand is pasir kan? Pasir is used to make glass. Okay? Tapi sand kalau compare dengan glass, sand lagi lambat. Okay. Alright, so here goes. Alright, tengok pen kita ni. Pen apa ni? Pen brand Tefal. Okay? So kalau you beli murah, okay, dia punya haba tak bagus. Okay? So that's why nanti korang balik tengok korang punya dapur mak kan. Tengok brand apa mak awak pakai. Tefal tu bagus lah, that's why sedap. Okay? Alright, so actually kalau masak sedap tu pakai brand apa pun sedap juga. Okay? Next. Okay, kita tengok sini. Normally here we use plastic pemegang. Some pan still use kayu. Okay, kenapa? Sebab muatan haba tentu dia tinggi. Bila awak masak, sini dah panas, tapi di sini kita tak nak panas sebab kita nak pegang. Okay, so muatan haba tentu tinggi means a good heat insulator. Dia lambat panas. Okay, so you kena ingat ni tau, kalau you guna muatan haba tentu, you kena kait or bad heat conductor. Okay, here dekat sini tapak lah tapak. Okay, so we have made of copper, normally made of copper. Why? Sebab muatan haba tentu dia rendah. Bila muatan haba tentu dia rendah, dia cepat panas. You buka api sikit je dia dah cepat panas, you dah start boleh goreng telur. Okay, right. Which also is a good heat conductor. Alright, and then kita ada badan dia. Badan is always made of aluminium. Okay, aluminium again is a good heat conductor, cepat panas, di mana muatan haba tentu dia rendah. Right? Okay. Sedap. Oh, there's still people coming in. Okay. To admit them. Okay. Boleh Thank you to those who tolong jawab juga. Pretty bar, which part that you don't understand that I need to repeat? Sure. Okay. Any other question, guys, about specific heat capacity? You know, something that's been going on in your mind for a while? No?
I think some of us don't understand a little bit.
Which part? Specific heat capacity?
Little bit.
Okay. Okay. Let's sum it this way. Okay. So we have so many types of substance or objects in this world. We have, kita ada kayu, kita ada copper, kita ada aluminium, kita ada besi, kita ada gangsa, kita ada emas, kita ada so many things. Okay, and they all have specific heat capacity. Maksudnya berapa banyak energy yang dia boleh absorb. Adakah dia boleh absorb cepat atau dia boleh absorb, I mean everything, semua benda boleh absorb, tapi sama ada dia boleh absorb cepat atau lambat. So
I get it now.
So okay, if let's say that object can absorb heat in a very short time, that means it is a very good heat conductor, which also means the specific heat capacity is low. Okay, whatever objects yang ada specific heat capacity yang low, yang kecil, maksudnya benda tu cepat panas. Examples? Copper, cupro, apa lagi, zinc. Okay, what else? Aluminium, mercury, okay, minyak, not necessarily semua jenis yang besi je. Right.
Can I ask you one more question?
Yes.
Why is ice's specific heat capacity lower than water?
Why is what?
Why is ice's specific heat capacity is lower than water? Yeah, it's in the diagram.
You are asking about ice, is it?
Yes.
Oh, because of the
Is it because
of the bonds. You know how solid the bonds between the molecules are, are tied together compared to water.
Oh, so it has something to do with latent heat, huh?
Yeah, yes, that's right.
Oh, okay.
Okay, all right. Okay, guys. Okay, so this is the example of application. Okay, actually kan, this is what we call the sea breeze and the land breeze. Sebenarnya kalau you ingat satu je pun cukup, sea breeze. Okay, compared to land breeze. Sebabnya, it all comes down to the darat dengan laut. Okay. Alright, so you tengok sikit sini. Real life situation. Kalau you jalan siang-siang tepi pantai, right? So normally the breeze ataupun angin dia akan kuat. Dia akan angin sejuk. So that's during the daytime. Okay, where does this angin sejuk comes from? Let's say you're standing here, right? So let's say you're standing here. During the daytime, okay, lepak-lepak kan? Okay. So we know that land ataupun pasir has lower specific heat capacity. Ni nampak? Specific capacity ataupun muatan haba tentu pasir rendah. What does that mean? That mean dia cepat panas. Suhu sama je, semua suhu datang daripada matahari. Matahari gives out heat. But here we have land, pasir, tanah, and here we have the sea. Tapi disebabkan air, specific heat capacity air is higher, dia lambat panas. Okay, so here what happens is that, memanglah panas kan? So, bila panas, udara panas akan sentiasa bergerak ke atas. Betul? Ingat balik, dia bakar sampah kan? Bakar sampah, asap naik mana? Asap naik ke atas. Because it's hot. Okay, udara yang sejuk, dia tak boleh naik atas because it's heavy. Okay, bayangkan you pasang aircon. Kenapa you pasang aircon dekat atas, dekat ceiling? Because udara sejuk tu dia berat. Dia akan turun ke bawah. Dia takkan naik atas. Okay, so here udara panas tadi, okay, yang daripada pantai tadi, okay, it will go up here, go up, which creates a low pressure. Okay, low pressure. So sini pula kita ada udara yang sejuk. Udara sejuk is heavy, so it cannot go up, but it can go there. It can move around. It won't go up, but it can move around. So why would it go here? Why would it go to the land? Because land has a lower pressure. So apa yang you kena? You dapatlah angin sejuk, angin dari laut. Kita tukar dia to sea breeze. Bayu laut. Bayu is angin. So bayu laut is angin from laut. Angin sejuk daripada laut. Okay? Faham? So the opposite thing happen during night time. Okay? Dipanggil bayu darat. So bila malam, saya pernah mandi pantai waktu malam. Mandi swimming pool waktu malam.
No. Takut jin keluar.
Hey guys, you should try, nanti kan. Siapa kat kondo tu kan, pergi masuk swimming pool waktu malam. Cikgu jamin.
Lembaga hitam macam mana cikgu?
Tak ada lembaga hitam, sekarang bulan puasa. Okay. So, awak pergi masuk swimming pool waktu malam. And you will notice air swimming pool is actually quite warm. Dia masih panas. Why? Sebab siang tadi panas, haba daripada matahari tadi, dia diserap ke dalam air dan belum habis keluar. Okay? So when at night, during night time, this is not just for sea lah. Kalau kat swimming pool pun sama actually. Okay, sea land breeze juga. Lebih kurang lah. Okay, so at night, sea is warmer. Okay? So when sea is warmer, land is cooler. So angin tadi dia akan berpusing. So sekarang ni bayu darat itu angin daripada land pula yang akan bergerak ke sea. Okay, so ni kita panggil ni perolakan lah, right? Perolakan ini just science, right? So that is when you have your sea breeze and your land breeze. So few key points yang you kena tahu here is, first you mesti wajib cakap pasal muatan haba tentu, specific heat capacity. You cakap pasal specific heat capacity pasir kecil, maka dia cepat panas. And then you also cakap pasal muatan haba tentu laut, dia besar ataupun tinggi, that's why dia lambat panas. Okay, bila you cakap pasal tu, baru you cakap pasal pergerakan udara. Menghasilkan kawasan bertekanan rendah. And then dia cakap pasal angin dekat laut. Angin dekat laut yang sejuk akan bergerak ke daratan, menghasilkan bayu laut. Okay, normally question macam ni memang 4 marks. So you have to explain. Mesti kaitkan dengan specific heat capacity. Okay? Macam mana angin panas tukar jadi sejuk? Sebab air laut tu. Yes, bukan angin panas tukar jadi air sejuk. Angin panas tadi dah naik atas dan dia di-replace, jadi diganti dengan angin sejuk daripada laut. Dia bukanlah bertukar tiba-tiba. It's actually angin kita tak nampak angin, tapi dia bergerak. It's a perolakan, dia pusing. Okay, dia pusing goes up and goes down balik. Yang panas naik atas, yang sejuk gerak bawah. Okay? Sure, boleh tak nak screenshot previous slide? Yes, replace angin. Screenshot previous slide. Okay, wait This one or this one? Okay, whatever needs to. I actually macam prefer you, kalau boleh you can relate it to real life situation instead of you guys hafal sand has low specific, because bila you hafal, sometimes bila you buat exam you will get yourself confused. Tiba-tiba cakap lemak sand low or high, tak nak macam tu. Bila you boleh kaitkan dengan you jalan-jalan dekat pantai ke, then it will come naturally, then it will all make sense. Okay? I'll share these slides in the YouTube nanti. Okay, I think ada dalam YouTube juga, so it should be no problem. Right, next. Okay, let's try. Alright, Raja menunjukkan satu blok plumbum, satu blok besi dan satu blok aluminium. Okay, semua blok mempunyai jisim yang sama dan dipanaskan dengan tenaga haba yang sama selama 15 minit. Okay, so semuanya sama, but the only difference is their specific heat capacity. Okay, pernyataan yang manakah yang betul di akhir?
Donkey.
Okay, so ingat balik guys, kalau specific heat capacity small, maksudnya dia cepat panas. Higher value means lambat panas. So, yes, D lah Suhu air blok plumbum adalah lebih tinggi daripada suhu air blok besi. Okay, So it's actually D. Okay, but because it's the smallest. Okay. Alright, next. Let's try this one. Itu kan jumlah tenaga haba yang diserap. Okay, so it asks you to determine the amount of heat absorbed oleh sebuah blok kuprum berjisim 2 kg. Okay, changing from 31 to 8. Right, so we know the formula. Q equals to MC theta.
2 times 49 times 390.
Yes. Ini memang sangat-sangat straightforward. Selalunya dalam exam, kalau dia nak trick you, dia akan bagi this one in gram. Let's say dia bagi you in 200 gram. So, orang yang lupa diri kan, dia terus dia letak mass ni 200. Okay, sepatutnya you tukar to kg. Okay, so this one, the answer is berapa guys? 38220, betul? Kira. Very straightforward. So bila minta you tenaga haba, means it's in joule lah. Next, number 2. Okay class, so you need to know that for specific heat capacity dengan latent heat, okay, kita ada formula dia yang Q MC theta kan, and remember to equals to MC theta. Belakang ni sama je. When to use this ni lah. Kalau that question involves macam dia bagi you some electrical stuff, okay, and then dia bagi you time. So this is when you have to use PT equals to MC theta. You jangan guna yang ni sebab Q ni you nak cari Q macam mana kan? Okay, so you ada P sekarang. P is power, tapi power mesti in watt. Here dia bagi you kilowatt. So you tukarlah 2,000. Time mesti in seconds. So 1 minute is 60 seconds. Okay, M mass 4 kg. C dia bagi dekat you, ya, 4200. Okay, so berapa kenaikan suhu? So you just looking for theta. So sorry sebab I guna mouse. It's quite hard to write with mouse. Okay, so I think jawapan dia is 7.14. So, okay, a lot of people ask me like, Cikgu nak letak berapa tempat perpuluhan, berapa decimal places. Okay, it's always safe for you to use 2 to 3. Okay, 2 to 3 decimal places. Kalau you dapat macam, kita katakan calculator you 7.5 je lah. Tapi kalau you dapat panjang right, 7.142893, you take 2 to 3 decimal places. Okay, and avoid rounding off banyak sangat sebab nanti dia akan affect you punya jawapan. Okay, so here right. Okay, next. Okay, this one I dah doodle, siap-siap. Okay, this is another example yang check my book. Ada orang tanya juga soalan. Mana? Question 1. Question 1. Question 1, which one? Oh, this one? The question 1 is just, sorry, ada orang tanya. It's just Q equals to MC theta. Straight away. Okay. The same is mass. 2 kg. Muatan haba tentu is 390. Theta is perubahan suhu. Maksudnya from 31 to 80, you tolaklah 80 minus 31. Okay, theta is perubahan suhu. how much the temperature changes. Okay, the difference in temperature. Okay, the first few slides. The first few slides. Yeah. Nanti you tengok balik the YouTube. Okay, so I have to proceed sekejap. Okay, this one. Okay, ramai orang confused. Okay, now this is soalan yang melibatkan mixture. Okay, tengok What is the final temperature when 100 gram of water at 25 degrees C is mixed with 75 gram? So basically macam ni lah ayat kalau dalam bahasa biasa kita panggil berapa suhu kalau you campur air panas dengan air sejuk. Okay, jawapan dia adalah dapat air suam. Betul? Okay, but in science, I need to know the exact temperature of this air suam. So here goes. So kalau I lukis, kalau you lukis, actually better lah kalau you lukis So here is you ada 100 grams of air sejuk, 25 degrees C. And then you ada 75 gram air panas. You campur dua-dua. So if this is your thermometer, okay, if this is your thermometer, air panas campur air sejuk, you akan dapat somewhere in between. Kan, betul tak? Somewhere in between here is theta F lah. Tapi berapa? Okay, now this is what we need to find. Theta F. Berapa? Now, ini air panas, masuklah air sejuk, air panas akan hilang haba. So kita panggil dia Q loss. Hilang, haba yang hilang. Haba yang hilang tadi, okay, this heat loss, pergi mana? Pergi dekat sini lah. Pergi dekat air sejuk. Which is Q gain. Haba yang dapat. Okay, haba dia hilang. Pergi ke haba, pergi ke air sejuk. Okay. And then bila you dapat macam ni, you letaklah Q. Q we know that MC theta kan? You equate it to MC theta. This one sama dengan MC theta this one. You know, please pardon my tulisan. Alright, so okay, you dah dapat MC theta untuk air sejuk dengan MC theta untuk air panas. Okay, now you kembangkan dia. Alright, mass is 0.1. 0.1. Okay, kenapa C ni kenapa teacher cancel? Okay, I tulis balik lah MC theta untuk air panas, untuk air sejuk sama dengan MC theta untuk air panas. This one. Okay. C kita boleh cancel sebab dia guna air yang sama. Ada orang nak tanya ke? Tak ada. Okay, so kita tengok mass. Mass ni 0.1 kg. Okay, theta. Theta ni, kalau you tengok balik dekat this one. Okay. Theta untuk air sejuk tadi. Apa ni? Air sejuk daripada 25, dia akan naik ke something. So this something is theta F. So you buat dekat sini theta F minus 25. Sama dengan, now kita ada mass untuk air panas 0.075. Okay, what about theta F? Untuk ini pula. Okay, kita tengok ni. Ni penting ni sebabnya asalnya air panas tadi 50 darjah Celsius. Now dia nak jadi, dia akan turun sikit. Dia akan turun jadi theta F. So you akan buat sini 50 tolak theta F. Alright. So this is basic maths. Takkan nak ajar you kan? Bukan. So last kali you are going to find theta F. Okay guys, siapa boleh jawab betul bagi RM5? Okay. Cepat. That's the right answer. Dia nanti bagi number account, bagi RM5. Anyone? Kira-kira. Mana student yang lain ni? Okay. So the final answer, you tengok, you kira, you mesti dapat in between 25 and 50. Kalau you tiba-tiba dapat 22, maksudnya salah. Kalau tiba-tiba you dapat more than 50, takkan you letak air panas campur air sejuk, tiba-tiba dapat air mendidih, kan? Takkanlah. So you akan dapat in between. Okay? Yeza. Muhammad Danish bin Abdul Aziz. Sorry, Jonathan. Patricia, so get right. So actually, Patricia, you betul ke you kira tu? The answer is 35.71. Okay. A. Okay, the answer is 35.71. Okay, kira balik. The real SPM question.
A.
Right. Betul. Senang je kan? This one is A. Alright, this one. Explain how the sea breathes. Ingat balik guys. 4 markah. What are the points? You mesti cakap pasal specific heat capacity ataupun muatan haba tentu. Muatan haba tentu darat ataupun pasir lebih rendah. Yes, bila lebih rendah, apa jadi? Akan cepat
panas.
Yes, bila cepat panas. Lepas tu you cakap pasal muatan haba tentu air laut. So muatan haba tentu air laut, specific heat capacity air laut is high. Maka dia lambat panas. Okay, kita dah dapat dah 2 points. 2 markah. And then you cakap, udara panas daripada daratan akan bergerak ke atas dan menghasilkan kawasan pertekanan rendah. Okay, itu 3 markah dah. And then udara sejuk daripada laut akan bergerak ke daratan menghasilkan payu laut. There you go, 4 marks. So you cakap specific heat capacity ni 1 markah. Specific heat capacity laut 2 markah. Udara ni naik atas dan hasil tekanan rendah 1 markah. Dan udara laut, angin laut bergerak, another 1 mark. You can do it in point form, don't worry. It's always good to do it in point form. You senang tengok, examiner pun senang tengok. Okay? Right. I think I have to stop now. And because it's only scheduled for 1 hour. Nanti I will try to record and sambung latent heat on YouTube. Okay guys, I know like this online classes is not the same as having face to face with your teacher, but at least you can shed some light to you and then bagi korang ingat balik, right, apa yang dah belajar during Form 4. And from now on, what you need to do is just look to SPM questions, okay, from year to year, and then try to do questions yang melibatkan soalan. Okay, from there you akan tengok. Basically dia tanya you more or less je, lebih kurang je. Okay, dia takkan tanya out of context sangat lah, right? So tadi alright. Okay guys, thank you for joining me, and kalau I salah ke apa ke, you forgive me, I might have overlooked some stuff. Okay, all the best to you guys. Thank you. Bye.